Alrighty, welcome back. So today's going to be your first actual note lesson on moles and stoichiometry. So last unit we did focus a lot on moles and converting from grams to moles and moles to atoms and grams to atoms. But we were always focusing on just one type of thing. So we were going from grams of carbon to atoms of carbon, or moles of Na2O to atoms of Na2O. In this unit, we're going to be focusing more on going from grams of one reactant to grams of a different reactant, or grams of one reactant to a product and atoms of that product. So going to different sides of the equation. Just like before, we're going to be going from grams to moles and moles to grams, but we're never going directly from grams of A to grams of B. We must always use moles as our central unit. So you should hopefully have a note packet that you found on Canvas. You should be looking at it. The front page looks like this. It just says stoichiometry. And we're going to start here, and you should see that image at the top of the page, and we're going to start with some vocabulary. So, stoichiometry. I know it's a crazy sounding word, and there's two different types of stoichiometry. The first is composition stoichiometry, and this shows the mass relationships of elements in compounds. Okay, so it's showing the relationship of mass, and remember that mass means weight, and we measure mass in grams. So for instance, it's basically showing that 1 mole of C6H12O6, so sugar, is 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. So composition stoichiometry is showing us how much something is made out of. So 1 mole of this is actually 6 moles of C, 12 moles of H, and 6 moles of oxygen, even though together it's 1 mole. Reaction stoichiometry then shows the mass relationship between reactants and products. So with composition stoichiometry, we're only looking at a singular compound, whereas in reaction stoichiometry, we're looking at both reactants and products in a chemical reaction. So we're not just looking at CH4, but we're looking at CH4, oxygen, carbon dioxide, and water, and how those all interrelate. Okay, and then another term that we need to know is a mole ratio. So a mole ratio is something we've gone over before, but not in terms of a mole ratio. We've talked about them in terms of conversion factors. So a mole ratio is a conversion factor that relates the amount of moles of any two substances involved in a reaction. And I know that's going to sound confusing, but a mole ratio could be as simple as this. So let me grab my little marker out. It could be as simple as 2 moles, this is messy, of carbon is equivalent to 1 mole of hydrogen. And you're going to be able to solve these by looking at reactions. And we're going to do some practice with that here in a second. So, if we have N2 plus 3H2 yields 2NH3, we can make several different mole ratios using this formula. So, if we have N2, 3H2, and 2NH3, one example of a conversion factor we could make is 1 N2, because notice there's a 1 here, is equivalent to 2 NH3. Okay, that would be 1 mole ratio we could make. Can you think of another mole ratio? Maybe you did 3H2 over 2NH3. Okay, so comparing our other reactant to our product. Just as a reminder, our reactants are on this side of our equation, and our products are over here. Mole ratios, however, don't always need to compare reactants to products. We can also compare reactants to reactants. So we could have 1 N2 is equivalent to 3, that's a 3, H2s. Okay? And this could also be 3 H2s is equivalent to 1 N2. It's really hard to make 3's with this for some reason. So I want you to go ahead and give it a try. What are all the mole ratios you could write for the following equation? So go ahead and pause the video and come up with some mole ratios that you could write for this specific equation. Some different answers could be 2Al2O3 over 3O2, or 2Al2O3 over 4Al, or 4 moles of aluminum over 3 moles of O2, or 3 moles of O2 over 2 moles of 2Al2O3. So those would all be different examples of mole ratios that we could make. Here's another one. Give this one a shot. What are all the mole ratios you could write for this equation? Okay, again, we could have 2 moles of Fe2O3 is equivalent to 3 moles of C, carbon. We could have 3 moles of carbon equivalent to 3 moles of CO3. We could have 4 moles of iron equivalent to 3 moles of C. Okay, so all of these can interrelate. Be sure to reach out if you have questions on mole ratios. So booklet making. This is something I did last unit with the in-class students, but we didn't do it with the online students. So I want to make sure that I just give you a general idea of what this is. And this is going to be really helpful to just keeping all of your notes in one place. So what I would encourage you to do is go ahead and grab, just like maybe you have a colored piece of paper, and if you don't, just white paper or some sort of scrap paper lying around, and just some other blank pieces of white paper. You're going to fold them all in half hamburger style to make a booklet, so it'll look like this with pages on the inside. Okay? What I would encourage you to do is make a booklet of all the important information that we're going to be covering in class, and just a note booklet basically to have all your notes in one cohesive spot. So what I would encourage you to do is, let me go ahead and pause it really quick and just pull up a Google Doc. Okay, so I'm going to pretend like this is the page of my book. I'll make my font a little bit bigger so you guys can see it. So what I would do is on the, whoa, not that big. On the first page of my book, I would just have common vocabulary. And I would include that in my book. I made this bigger and then it didn't do anything. Come on. Oh my goodness, I'm really struggling. Come on. Okay, so common vocabulary. And today we learned a couple different vocab terms. We learned the word composition, stoichiometry. So I would list composition, stoichiometry. Maybe you want to give the you want to define it, give an example. And don't define it exactly how I defined it in my video. Maybe define it in a way that makes sense to you. This is to help you study, to help you have something to look at when you're ready to study for this test. Okay, so add in composition stoichiometry, add in reaction stoichiometry, add in mole ratio, give an example, tell me what is a mole ratio, how do you find a mole ratio. Okay, if you want an example of a page out of my book, go ahead and look down a little bit further and I can show you what I put for mole ratio, for instance. Okay, and we're going to be doing this for every single unit, so I want you to, or not unit, sorry, every single new thing we learned during this unit, so I want to encourage you to add to your book throughout this unit so you have something to study from. Okay, let me hop back over to our PowerPoint. I think that was all I want to cover in this specific video. Yep, we are going to continue today by watching another video on stoichiometry, so tune into that next one. Thank you.